Okay, number 26, chapter 2. There are 3 things you need to know perfectly well, clearly, to do this problem. One is how to calculate the molar mass. Previous problems have done it. I'm sure you know how to do it, but I just want to review. Molar mass is the mass of a mole. So if we're talking about atoms, it's the mass of a mole of atoms. If it's a molecule, then it's the molecular mass. So the mass of a mole of that molecule. If it's an ionic compound, it's called the formula mass. It's just NaCl. That's the formula for that ionic crystal. You calculate the atomic mass of the sodium plus the atomic mass of the chlorine, and you get the formula mass. It's all the same thing. We're going to call it the molar mass for now, and you get it from the periodic table. Up here we have copper. This number at the bottom, it's called the it's the unified atomic mass unit, and we're just going to use it as a mass unit. We're going to stick grams on it and say this is how much a mole of copper weighs, 63.546 grams. Okay, so that's the first thing, the molar mass. You need to know how to calculate that. Then the 2 definitions of a mole here, each of them will give you a unit conversion that will be necessary to solve this problem. So the first one over here says the amount of a substance that contains Avogadro's number of particles. That is a mole. So coming down here, you can ignore that, it's just a repeat. Avogadro's number of particles, 6.02 times 10 to the 23rd particles, equals a mole. So that's a fraction. It equals 1. That's why we can use it in unit conversions, because unit means 1. Okay, so that number of particles in a mole. And then the second definition of a mole says the amount of a substance that contains the same number of particles as in 12 grams of carbon 12. And you should recognize this 12 grams of carbon 12 as the atomic mass of carbon. So I just wanted to show you that carbon has a 12.011 atomic mass. The 0.001 reflects the different isotopes of carbon, but that is what we're talking about. A mole, you could say the mole is equal to the molar mass. So this 12 grams of carbon is like the molar mass of carbon if all carbons only had 6 protons and 6 neutrons. So here we have a second unit conversion, molar mass to mole. Okay, this is all you need to solve this problem. So now it's going to be pretty quick. Okay, we're starting with 73.2 grams of copper, and we are going for number of atoms. So let's start over here, 73.2 grams. We're going to put it over 1, just so it looks like our unit conversions. And now we want to cancel grams in the denominator. So our first unit conversion is going to be grams on the bottom. And what's in grams? The molar mass. So we're going to look up the molar mass of copper in the periodic table. I'm going to read it, 63.546. And because this is only one element, it is the same as the atomic mass. It's only one atom of copper. Molar mass from the periodic table. And then we're going to put that over 1 mole, right? Because the molar mass and the mole are equivalent. Okay, so now we've converted our grams into moles, but the problem asks for number of atoms. So what is the unit conversion that converts number of particles to moles? Pause the video, figure it out. Okay, it's right here. So 1 mole is Avogadro's number of particles. So 6.0221 times 10 to the 23rd. Sorry, came out of that parentheses. Okay, cancel the moles. And now you have particles of copper. So doing the math on your calculator, you're going to get 6.93698 and on times 10 to the 23rd copper atoms. But yes, we do care about significant digits. So we're going to go back to the problem and say this is all multiplication and division. So we're going to use the least number of significant digits, which is 3. So we're going to round this number to 6.94 times 10 to the 23rd copper atoms. Done.